Welcome to this video. The topic is test on cement. So this is a continuation from my earlier video, which is introduction to concrete technology, where we have talked about all the advantages and the pros and cons of basically concrete and what do we cover in concrete technology. And there we had covered the topic that is cement. So we have talked about the manufacturing of cement and also the hydration of cement, the chemical part of it. So in this today's slide, what we are talking about is a test on cement. It is important because cement, as we know, as a layman knows that we buy in bags. So how do we understand what quality of cement it is and what are the precautions of knowing, because the good quality of ingredients will lead to good concrete, right? So moving with that, so what are the type of tests that are available to us, right? So there are basically two types, as we can see in the slide. One is field test and another is a laboratory test. So field test is basically which we do in situ, that is on site. So whenever on site we are having cement bags are coming in and we have to do a quick check before construction. That's what we categorize as field test. We'll cover in this slide, in the next slide. And the other part is laboratory test, laboratory test which we do meticulously in labs, labs on site also, and in other quality control sections also. So there are few tests, that is fineness test, setting time test, strength test, soundness test, heat of hydration test, and chemical compositions test. Each of these tests is very important, and why do we do it? I'll cover in the next part of the video. So moving to the field test. So as soon as we get a bag of cement, on the site of the construction, the first and foremost thing that we should be checking is the date of packaging. So date of packaging will it's very important because according to our IS code specifications, if a cement is stored more than 3 months, right, it should not be used. Okay, it should be sent to lab for testing, right? So preferably we should check for that. Then is a part visual inspection, like if we have a bag of cement, how do I know it is nice or it's okay or not, fit for construction or not? So if you open the bag and you see lumps, okay, lumps of cement, so that is a very no sign. We should not be taking it. Also the color of the cement should be greenish green. So this two factor is quickly you open the bag and you see, and that's it. Okay, next is the sensory test. Sensory test is that ideally if I open the bag and thrust my hand inside, okay, I should have a very cool feeling. Okay, it should feel cool. And also other thing is that if you take a pinch of cement in your hand between fingers and you just rub it, you will have a very smooth feeling. So this is a sensory test for that. Another is a flow test. That is what you take a handful of cement and just throw it in the bucket of water, and you will see the particles of the cement floating for certain time before they sink. Okay, sink into the water. So this is called a float test. Is another means of it. And the last one is a way where what we are seeing is we take around 100 grams, okay, of cement and some water and make a stiff paste, roughly a size of a cake kind of thing, make sharp edges. And then what we do, we put a glass plate and we put it under the water. Okay, so while we are putting it under the bucket of water, the shape should not be disturbed. Okay, first thing. And also after 24 hours, the original shape whatever we had made, right, that should be intact, and also some strength of has been gained. Okay, so this is called consistency check. This is also one kind of field test we do, generally we do. So these are the ones you can do on site. So moving to the lab test. In the lab test, first and foremost we'll be covering that is fineness test. Fineness of cement is very important. Fineness is what? By fineness we mean the size of the grains of the cement, okay? And we must understand, like if anything, any particle which is very small, right, it will have more surface area. So if it has more surface area, so attack of water will be more, right? So the development of strength, that will be also very fast. So this fineness of cement is a very important factor because it influences the rate of hydration, the speed at which the strength gain is happening, also the heat evaluation during the whole process, okay? So there is a and all this test, everything is specified in certain different is codes, specialized is codes. So for this particular test it is is 4031 part 1 1996. Okay, so the title is method of physical test for hydraulic cement part 1 determination of fineness by dry sieve. Okay, so this is one. So fineness of cement. So next we have is setting time test. Now setting time test is basically aimed at understanding or attaining the time which a cement takes to set. Okay, now what do we understand by setting of cement? That is initial setting time and the final setting time. So before going to that definition, what is the code? That is IS 4031 part 5 1988. Okay, so this is the code which has initial setting time. That means the what is initial setting time? That is the time frame when the water comes in contact with the cement and it mixes until the paste begins to lose its plasticity. So that is my initial setting time. And this initial setting time is very important because it is very, when we are handling the concrete, or we need to transport our concrete from in a long distance or small distance, whatever is the distance, like we have to transport it. So there needs to be certain time before placement, okay? And also during placement we need certain time. So that time frame within which I can easily do the handling, transportation and placement part is what initial setting time should coincide with. So this is a very important aspect. And then there is a final setting time. Now what is a final setting time? It is the point when we add water to the cement and it completely loses its plasticity, okay, sufficient to resist any certain amount of loads, okay. So this is a important factor because it influences the it is like this is the total time. Final setting time is the total time within which my whole construction work should be over, okay, because after that the concrete is already gaining strength and it is becoming stiff. So before that all the placements will happen. So this is one very important parameter. So next to this is my soundness test. What is soundness test? Okay. See, it is basically expansion in cement. In a cement, as we have discussed in my earlier video of concrete technology, we had discussed about certain chemical compositions in my cement which when coming in contact with water it leads to the form of gel, and that gel is expansive in nature which due to swelling, right? So this now if there is an excessive expansion within my mortar concrete, there will be cracks, obviously there will be cracks, right? So to detect any this excessive expansion in cement after setting, this particular test is known as the soundness test. Now what is this? Uh, this can cause as a result of excess lime, right? And also this can be happening like if there is inadequate burning, insufficient fineness, the fineness of cement is insufficient, or improper mixing of raw materials during cement production. Okay, this all things in combination or independently will lead to this any excessive expansion in cement. So this is what a soundness test is for, and the detailed procedure can be found in IS 4031 part 3 1988. Okay, moving to the next part, that is heat of hydration test. Now what is heat of hydration test? It is the like heat of hydration we have already discussed, like when we add water to our cement, what is happening is it is an exothermic reaction. So a lot of heat is being released. Now this is a very important issue, particularly in case of huge construction like dams, okay, where huge amount of concreting is happening. So there the heat of hydration, that temperature is quite high. So it is very critical and very important to minutely understand what and how much temperature is happening. Okay, if we know how much is happening, then is when we can find solution, and maybe we can find ways of controlling it or rather find solutions to it. So there is a specific instrument called calorimeter which is used to measure this heat of hydration test, and the whole procedure is followed according to the IS 4031 part 9 1988. Okay, so this is a very sophisticated and very important and critical test, I will say. So moving to the last one, that is my chemical compositions test. Now chemical composition test is very important because not my all cement like as we have seen, cement is made of many components, many chemicals like silica, CaO, lot of the smaller constituent parts are there. So chemically, a lot of elements are there, right? Now, depending on the sources from which the particular cement has been made, these percentages of all the elements may vary. Now, the good elements may have a higher ratio, or the ones the alkali content or the minor oxides, they might also vary or be in excessive amount. So, whatever is the case, anything beyond the defined percentages, which we have discussed earlier, is not good. So, what we do is when the resultant cement, whatever we are getting, we should send that for chemical composition test to check that the important components like silica, alumina, iron oxide, calcium oxide, magnesium oxide, and others, whichever all those which was listed, we have to check that all of them are present in the predefined proportion percentages, because each of it, it directly impacts the property of the cement, and also the heat of hydration, the setting time, everything is influenced by this composition, right? And hence the whole concrete and also the structure which is being constructed using this particular concrete will be influenced. So this is a very important test, and this is done by following IS 4032 1985. Okay, so with that we come to the references which has been used for this study, and thank you for following this video. Thanks.